and gentlemen, a massive asteroid named Etiam is currently heading towards the Earth. Etiam is described as having an irregular bone-like structure. It is extremely large, measuring about 78 kilometers long, 20 kilometers wide at its thickest point, and 12 kilometers wide at its thinnest point. Etiam is also very heavy with a mass of 6.89 times 10 to the square root of 15 kilograms. It's traveling through space at a high speed of 103,450 kilometers per hour, and it's moving directly towards the Earth. Right now, Etiam is located about 104.7 kilometers away from Earth, just outside the asteroid belt. Based on its current speed, scientists are concerned that it will collide with the Earth. If Etiam collided with the Earth, the impact would be catastrophic and life-threatening. And objects of this size would release more energy than millions of nuclear bombs. This would destroy countries, create massive fires, and cause huge amounts of dust around the Earth. This would cause climate change, the collapsing of food systems, and most living species going extinct, including humans. Today, our team will be explaining the situation and discussing how scientists and engineers are working together to prevent this collision and protect the Earth. Let's see what our lead director, Professor Ali, has to say about this.
Good morning, everybody. I'm the lead scientist, Fatima Ali, and thank you, Aisha, for letting me speak on this matter. Our team of scientists plan to stop Etiam from hitting the Earth by sending a device into space that has two big heavy metal bars. We do not want to destroy that asteroid. Instead, we want to deflect it away from the path it is currently on, which will affect Earth if not deflected. Deflecting the asteroid would be a safer method rather than breaking it, because breaking the asteroid could make many small pieces that still can hit Earth, and that's risking people's lives. Now, our associate director, Professor Fateh, is going to further explain why we chose this strategy.
Ladies and gentlemen, I am Professor Mahmoud Pateh, the Associate Director of this project. Our chosen design is not only efficient, but it's also highly effective, thanks to its straightforward structure that achieves trajectory deflection. Rather than to destroy the asteroid, it successfully guides the asteroid away from Earth. This approach depends on the device having significant mass to transfer enough force and momentum during the collision. This is crucial for altering the asteroid's path.
Send the device into space, scientists must place it in the exact right spot. If it's not in the right place, deflection might not work. But if it is in the correct position, the heavy metal bars will push the asteroid when it reaches them. Because the metal bars have a lot of mass, they also create a greater gravitational pull. This means Etiam will slowly be pulled toward the device as it gets closer. This helps guide the asteroid into the right position so the device can push it away. Even a small change in the asteroid's path can make a big difference over time. So by pushing Etiam early, we can make sure it misses Earth and keeps everyone safe.
We tried experimenting with other designs. Some of them were successful and some weren't. For example, before this, we tried to make a large ramp of some sort that would allow the asteroid to divert off the ramp and deflect it away from Earth. The main reason why we decided not to do this design was because we realized that there was a chance of the experiment not working, and when we tried using the prototype and tested it with an asteroid simulation, the ramp failed 2 out of the 5 times we tested. This might seem like a solid chance, although this is a solution for around 8 billion human beings on Earth, so we can't take any chances. After testing many designs and models, we landed on this one. We chose this one because out of all the tests, this one came out with the highest result of 4.9 out of 5, which was the best one out of all of them. To be frank with you, there are 2 big things that could go wrong with our plan. First, we have to hurry up and send the rockets early. If we wait too long, the space rock is too fast and our push won't work. Second, it's very hard to aim because the space rocket is super far away, and if the rockets miss even by a little bit, the giant pusher won't hit. If the space rock is coming for Earth, the biggest danger is hitting our air. When the rock slams into the air, it will make a giant heat wave and a huge boom, such as like a shock wave, that can knock down everything for miles. Plus, all the dust flies up and makes the sky dark, which makes the whole world and the weather messy. Our plan stops the air disaster from happening.
Device into space, we would use a strong rocket to carry it up past Earth's atmosphere. The rocket would place the device on the same path as the asteroid so it can meet Etiam at the right time. To keep the device in place, we would give it small thrusters that can make tiny adjustments. These thrusters help it stay steady and not drift away. The device would also have sensors that tell it if it is moving off course, so it can correct itself and stay in the right perfect spot.
As we've seen today, the asteroid Etiam presents a serious and potential life-threatening danger to our planet. But thanks to the work of scientists and engineers, we're not facing this threat alone. Our team Deflection's plan, using 2 high-speed metal impact bar to gently push Etiam off its path, gives the Earth a chance to avoid this asteroid disaster. Thank you.